All right, we are live. Good morning, everybody. I am Vino Duraisamy, a developer advocate at Snowflake. And today we are going to talk about a very interesting feature and topic. You have all heard from Snowflake Build Conference about Snowflake Interactive Analytics. To tell us more about it, we will have today Will, who's a principal product manager currently building Snowflake Interactive Analytics. He focuses on building tools for developers in real-time analytics space, and he has been a product manager for several open source databases, including Apache Druid, Hive, HBase, and Phoenix. He's also ran products at Meta, Microsoft, and also been the first PM of Datadog, with a lot of data, analytics and real-time platforms under his belt. He is here today talking about Snowflake Interactive Analytics. Welcome, Will.
Vino, thanks a lot for having me today.
Right? That was the loaded introduction. You have amazing experience under your belt. And look at all the open source databases you worked with. That's fantastic. But tell us all about what are we here for today?
Yeah, today we're going to talk about this exciting new feature called Snowflake Interactive. And it's designed to accelerate a lot of interesting workload on top of the platform.
Right? And I know interactive analytics was announced at Snowflake Build, and it sort of was easily one of the most popular features from the community. Everybody had questions about it. And I had folks ping me and ask, when will the documentation be live? I'm trying to get my hands on it. And I'm like, today's the day, guys. And tell us a little bit about what exactly is interactive analytics and when would I use it, or what can I build with it?
Yeah, so Snowflake Interactive is a pair of features. We have a interactive table that has additional metadata index in it. And then we also have a specialized hardware set we call Interactive Warehouse. When you attach a table to the warehouse has a specially tuned engine that will accelerate your workloads. But the gist of it is it will make your queries run faster, much faster, especially when it's under load. So if you think about a few 10, 15 years ago, a lot of the observability platforms like Datadog, for example, we have alerts setting up and you're driving a lot of concurrency. And before that, there was BI dashboard. There's a lot of people who are accessing real-time dashboard. These days, we see a lot more agentic workloads, right? So we're seeing AI agents generating massive amount of queries. And then if you can make each of the query run, 3-5 times faster, you get a much more interactive experience for your agents. So Snowflake Interactive is basically designed to accelerate those kind of workload, right? Whether it's observability alerts, whether it's AI agent, or it's simple dashboards. And we're here to power those applications.
Got it. I loved how you said it just makes querying faster. I'm like, well, if only it was that easy. Or maybe it is that easy with interactive analytics now that we have them, right?
Yeah.
And a little birdie tells me that you have a cool demo that will help us better understand how interactive analytics is different from traditionally, querying Snowflake data. Can you maybe show us? Yeah.
Yes. I'd like to show you a very simple and straightforward demo. What you have here is we have a query client, this little thing on the left side, that drives some workers, and then I have a data set. So the first thing I'm going to do is I'm going to run 500 queries concurrently with standard Snowflake. And you have to believe me, this is on the same hardware. This is fully reproducible, right? If you want to do this externally. And we'll measure sort of the query latency of running this workload. Let me see, is it actually running? Okay, I didn't click the run. And then what it does is it will measure sort of the query latency and then show you how long the query has been taken at 500 concurrency. Let me see. Refreshing. Oh, hey, it is not refreshing. I wonder why. Okay, I have to come back to this demo a little bit later. So I'm going to go into the prepared content first, and I'll come back to this demo.
No worries, yes. But yeah, tell us more about interactive analytics. What is it? When would you use it?
So there's 3 sets of things that you will want to do with interactive table. The first one is you will have a powering live dashboard, as I've mentioned, right? Really low latency interactive dashboard. The second set of things is data-backed APIs. So this means if you power and use APIs a lot, what you will do is the APIs will have a lot of requests coming in, and then you want each of the requests to have very low latency, very consistent latency, and then this is what you can get with interactive. And then the last piece is, as I mentioned, alerts, programmatic agent queries. What's common to those use cases, they all require fresh data. They require very low query latency, very, very high concurrency, and very low cost per query, right? And then this is like fairly ideal use case for Snowflake Interactive. Actually, it will be ready. Is there any way I can switch this over and then try to do a quick fix for the demo and then see if we can get it running, or should I keep going with the content?
I think we can, we can do this maybe. We can go over what exactly is interactive analytics and sort of talk about how it works under the hood, how is it different from standard warehouses and such. And I will spend some time summarizing what we've learned and maybe go over some of the audience questions. Meanwhile, we can give that a chance.
Sounds good. Yeah, let's keep going. All right, so let's talk about what are some of the key benefits, right? So the first one is we have done a lot of benchmarking internally when we're building this feature, and the first one is we're having a much higher queries per second. So this means for any kind of concurrent workload, you should see substantial improvements, right? For concurrency. The other side of this coin is imagine you need a lot of power to run, let's say you have 1,000 queries per second, right? And then you need a lot of power to power this kind of workload. With higher concurrency support on the equal amount of power, you will see substantial cost saving. Effectively, what this is telling you is it's 9 times cheaper for the right kind of workloads, right? And then the other thing that we have also done some benchmarking on is for single query latency, right? So this is a query that takes 3 seconds on a standard Snowflake Gen 1 warehouse will take basically 1 second to run on Snowflake Interactive. So you're seeing not only acceleration of concurrency, but even for single queries, you're seeing a substantial performance improvements when compared to standard Snowflake. And then what's even cool about this is Snowflake Interactive is priced cheaper than standard Snowflake. So it's 60% of the cost of a Gen 1 warehouse. So not only it's faster, it's also cheaper for the right kind of workloads. And we think that's pretty exciting.
Yeah, this is definitely exciting because we always think about performance and costs in a trade-off sort of sense, right? Like if you want high performance, it's got to be costly. So this is definitely exciting. Tell us how this is happening. Why is it possible?
Yes. So under the hood, so let me first talk about where this fits in. This feels kind of complicated, but this is sort of like a standard, traditional data platform that you will see, right? So you have the orange pieces, which is your, client-facing application. This can be a website, can be a mobile app. And then usually in the middle is you will have some ETL tools that post data, dumps it into a lake, and then you have a data warehousing solution that queries your lake, which powers your dashboard and API report. This is how most modern data applications are structured, right? You have the transactional side, you have the lake side, and you have like the surfaces. And then Snowflake Interactive sort of fits in into this lake layer, but it helps you lower the freshness. So instead of taking minutes, hours to refresh, you can refresh this table within a few seconds. And then the other thing is you get very, very low latency on your surfaces. So this is where it fits in. How this works there's 2 pieces. The first piece is we have a new table format. The new table format is built on top of Snowflake's table format, but with a little bit more metadata. It has different compression. It has different storage format. So it's optimized for reads. The other new thing we're introducing is there's a new warehouse. The warehouse runs on dedicated specialized hardware. And then it has a fine-tuned Snowflake engine that will take advantage of the metadata in this new table format. That's how you get the acceleration, by marrying this table format to the new hardware we're producing. And then once the table is attached to the warehouse, when you run queries, you get accelerated performance you're seeing earlier. This is also where the cost optimization comes in. Interactive warehouses are priced to be much cheaper than standard warehouses. And then this is where you're seeing that 40% cost saving compared to Gen 1.
Oh, I see. Okay. I think this is a good time for me because, to be completely honest, I've also been a data engineer in the past and I've been in this space. And this is a super exciting feature for a data person to be thinking about. And from a data engineer's point of view, maybe this is my time to summarize and like sort of show this is my understanding of what exactly interactive, tables and warehouses are, how they help and everything. Do you want to
Yes.
go to the tab of the demo?
Yes.
Awesome. And for folks who are watching, I have two questions. One, if you had anything that you wanted to ask about interactive analytics, what is it? Since when is it available? What is the documentation? Like, do you want to get started with it, build some demos? Is there a quick start that you can get started on? No questions are off the limits. Throw your questions in there and we will get to you. Like Will and I will help you get on all your questions answered. Secondly, you heard from Will, right? Interactive analytics essentially combines or comprises of two components. One is the interactive tables themselves and the interactive warehouses. Tables, again, we all know a Snowflake table is just a different table type, but the interactive warehouses are the compute machinery behind that makes this acceleration also possible. And one big differentiator that Will talked about was that when you are, say, running a query with just one user, or there's not a lot of load on the machine, it's probably easy and you have more predictable, consistent latency for your query. But if the query load increases, like if the concurrency increases, suddenly 1,000 users from your organization start using the specific app, and now you would see that the typical query engines would start to struggle. This is exactly where the interactive analytics come in, meaning even when your query concurrency increases, like the user concurrency increases, you will be able to have a consistent performance latency across the board. So that's sort of like the one-liner for why interactive analytics and why you should be excited about it as a data engineer. With that said, Will, I see you're back here. Let's see the demo.
Yeah, the joy of running live demos, right? And what I'm going to do is I'll go back to the demo. I've reset it. And what you all see here is I already have run one set of queries at 500 concurrency. The data plot you're seeing here is, on average, the query takes about 0.6 seconds to run, roughly. And there are some variances like in the query. What I'm going to do is I'm going to switch over. It's exactly the same data set, exactly the same amount of power at basically 40% lower cost, running 500 queries concurrently with interactive. And what you all see is a much lower query latency per query basis. Let me see. Oh, I think I also need to attach the table again. One more second. One more second. Flights, right? Okay, so flights. I think I should try to avoid doing live demos again.
No, well, we know at least this is real, right? Because sometimes it's in a virtual setting. What is a live demo and what is a recorded demo? You should do more live demos. This is good.
Flights interactive, flights delay interactive. Okay, flight delay interactive. Let me try this again. Flight delay interactive, place name and editor. Flights. Yeah, I think we should probably avoid doing this and then resume sort of our prepared content. Yeah.
No worries. Okay.
All right.
Now, firstly, we summarized what exactly interactive table was, when we would use it, but tell us more about it, right? Like because interactive table is a new type of table, how do I ingest data? How does it refresh? Like, is it anything different from a standard table, or what should I know about it?
Yeah. Okay. So let me talk about a few things. One is interactive table. You can fully refresh the table with a CTAS query or insert overwrite. So this means if your data is in any batch sources, You specify a clustering key, and then what we'll do is we'll do a full ETL job for refreshing this data and then attach it to a table. What's sort of like not working with the demo today is I think the refresh process is kind of broken, and we're probably running into some infrastructure hiccups there. The other thing that you can also do is your data can shift and change over time, especially for people using a data lake. You're dumping more and more data into the data lake. What you can do is you can specify a refresh frequency, and what we'll do is we'll automatically pick up the new data you have in the lake and incrementally add it to the interactive table in the interactive warehouse. This way you can serve batch source data basically as the upstream data source evolves, and you will always have fresh data in your API or your dashboards.
Got it. I have one quick question here, because
yes.
In my understanding, when I think about interactive table, I'm also thinking about interactive warehouses. But I see here that when we create this interactive table, I'm only using my standard warehouse. Is it because it's ingestion and not the querying side of things? Or what? When would I use interactive warehouses with standard warehouses when I'm thinking about interactive tables?
Yeah, that's a great question. And talking to a lot of people, I think this is a important thing for us to clarify, right? So interactive warehouse themselves are designed for accelerating query workloads. This means you are powering read-only queries effectively, right? Your dashboard is reading data, your APIs are reading data. Where Snowflake itself is a very, very powerful general purpose analytical engine. That means it's very, very good for doing data transformations and movements. And interactive warehouse or the table format, we leverage the standard engine. This can be Gen 1 or Gen 2 warehouses where you have some definition of like, I have my raw data. It might be in JSON, it might be in Parquet, and I only need certain columns. I want to do certain aggregations on top of it. What you can do is you can define all of those as part of the refresh definition or as part of the CTAS query that you have. And then you can execute on standard Snowflake warehouse. And then the standard Snowflake warehouse is what's responsible for doing the data transformation movements, where once you are done with the new format, you get accelerated query performance with interactive for reading queries.
Is it fair to think about interactive warehouses as read optimized warehouses?
Yes, it is. It absolutely is. Yeah.
Right. So then only on the reading or the querying side of things, I would think about interactive, and elsewhere, standard warehouses work better for me.
Yes. Yeah. I'm going to show you a different demo, and that will sort of describe how this thing like works. So one thing that we have talked about earlier today is you have the interactive warehouse, and what you are doing here is you create an interactive table out of this. So let me show you this. So what you do is you take a regular table, pump it through a standard warehouse, and then you get an interactive table. In this case, this is using like a CTAS statement, basically. Once you have the new table, you do this attachment between the table to the warehouse. So in this case, what I'm doing is I'm using my demo database, and I'm attaching this like demo table to the warehouse, right? So let me run this. And once you are done with this, what you can do is you can, just to make sure I'm not cheating here, right? I'm turning off the caching for the queries. And I'm going to run some queries on top of the interactive table. And you're seeing here is you can plot a chart, you get 0.14 second of query latency with interactive. What I'm going to do differently is I'm going to take the same table, right? So you're seeing what's the table I'm querying? I'm querying public hits to table. And I'm switching over to a standard warehouse. I'm using the extra small warehouse with interactive. It's the same, right? I'm also having caching off, same database, same query shape. And then I'm going to run this query again on standard warehouse. As you can see, much higher latency, right? Compared to the standard table, interactive table. So this will be sort of a comparison between interactive and standard, and then go back to your point of, how do you push data through? Why do you need the standard warehouse? This is mostly there for converting any format you have into this new optimized interactive table format.
Got it. This is helpful. And I guess even in this example, you had only ran one query and we could see the difference, right? And then of
Yes.
course, when you are running concurrent queries, this difference will be amplified, multiple folds, and you can see why interactive warehouses could be better, especially when you have concurrent queries.
Yes.
That's helpful. And tell us about like what happens when I'm using a join statement in my queries, or basically when my query gets a little more complex, complicated. Would this work? Should I keep anything else in mind?
Yeah, so that's a great question. A big reason why we're building this on top of Snowflake is because Snowflake is one of the best join engine out there, like in the world. And we're taking full advantage of that, right? So not only join queries works, any kind of window function, any kind of common table expressions, subqueries, etc., they all work great on interactive. And then the way it works is there's some limitation constraint, right, for this. The first one is if you want to run a join query across a bunch of interactive tables, they have to be attached to the same warehouse. This is so that the cache are warmed together, and then the query engine can find all the data it needs to do the acceleration. But some users, they're like, I have ad hoc queries, right? I don't have all my data prepared. Maybe some of my data are in a data lake. Maybe some of them are interactive. So the alternative is you can use a standard warehouse, any kind of Snowflake warehouse, and join across them. So there's no constraint, and you can sort of mix and match between interactive and standard table with the standard warehouse. The only limitation is if you want to get this like super accelerated experience for dashboard, you just need to attach your tables to the same warehouse.
Got it. This makes sense. And then even when I'm querying, I see that interactive tables are always attached to an interactive warehouse, but it could also be attached to a standard warehouse if
Yes.
that's sort of like the constraints that you're working with, and it's perfectly fine. But it's just that, of course, we would recommend you that you use an interactive warehouse so you can take full advantage of this combination, interactive warehouse and table.
Yes. Yeah. And then what's kind of helpful here is you don't have to duplicate your data because essentially if you have one copy of your data in the interactive format, then it can be accelerated or it can be accessed by both standard and interactive warehouse. And you can do complex queries on one side, and you can do like very targeted and accelerated query on the other side.
Got it. Yeah, I think that's even more helpful to know. And it's probably my question, but also I have a LinkedIn user. I can't see their name, but what they're asking is cheaper warehouse, better performance. It seems so obvious, but why isn't this a default pattern? Like, why is it something additional that I have to, actively set up and create? Tell us more about it. When should I not use? When should I use?
Yeah, I think this is like a great question, right? It's cheaper, faster. Why not make this the default, right? So a few things. One is the way that we implement the acceleration is by pre-warming the cache. It's a big part of it, right? So this means you get less elasticity, but you get better consistency. So part of the product design, the interactive warehouse is always up and running. There's auto scaling. You can always scale it out, but will never auto scale back down to zero. You can manually spin things down if you wanted to, right? So this is fairly ideal if your workload is consistent or you're powering something on 24/7. It's less ideal for workload where it's data scientist or I'm doing a lot of ad hoc query. The other limitation is we really want to make sure everyone is having a good experience using interactive warehouses. So that means queries running longer than 5 seconds are not supported. This means if you have someone running a 1 hour query and then the other one runs 5-second query, they don't compete for resources between each other. So that's why there's a hard cap on each query taking not longer than 5 seconds. And then lastly is, this is read-only effectively as a warehouse. So you should use standard for ETL. That's why this is also not the default, where with standard, you can do a lot of data transformation and other things. So this is mostly powering, dashboard APIs and read-heavy queries. I hope that answers the question.
No, it definitely did. I think first thing is that, of course, interactive warehouses and interactive tables are targeted at specific use cases where you have real-time analytics. So like when these tables are powering real-time dashboards or APIs or agents, really, right? And if it's not a real-time, like 24/7 low latency requirement, if it's just an ad hoc query that you run every once in a while, I don't know if interactive tables are the right way to go. So that tells you it's more of even when you have a low latency, high concurrency requirement, you're able to get better performance and cheaper warehouse. It's more of on one extreme of the spectrum, typically where costs will be high, performance would be low. We are able to achieve the opposite. It's not that across the spectrum you will be able to get that regardless, because again, these are targeted at specific use cases, and those use cases are real-time analytics. And I think Shantanu Chaudhary, I feel like this is a good time for us to get into one more question. His question is, are we saying we do not need multi-clustered warehouses or query acceleration service anymore? Or when should I think about interactive? When should I think about query acceleration service, multi-clustered warehouses? Like, are you able to help us there?
Yes, yeah. I might have a slide on multi-cluster warehouses. So the way to think about this is multi-cluster warehousing is really good for horizontal scaling. Let's say, depending on query complexity, right? A small interactive warehouse is able to handle 200 query, maybe 400 queries concurrently. And then you have a concurrency requirement of 1200 at the peak, and then 400 when the cluster is not as like loaded, right? So in that case, what you can do is you can use multi-cluster warehousing to do horizontal scaling to meet the query concurrency load demand. If you go from 1, you're going from 400, right? And then you go to 2, you get 800 concurrency, and then go to 3, you get like 1200 concurrency, which will meet your query concurrency demand. So that's where query multi-cluster warehousing scaling comes in. The other question is around query acceleration service. So for those who don't know, query acceleration service is Snowflake way for offloading scan-heavy queries, right? So if you run a query that requires just like pure raw power, like scanning a lot of data, Snowflake will spin up essentially separate containers in the background for you to run the scan for you, right? And then return the result for you. And it's pure elastic. This is not the right use case for interactive in general, because if you think about like query acceleration, you're scanning massive amount of data. And that usually takes like a long time to scan. So interactive, given there's a 5-second timeout limit, that's probably not the right use case for it. And usually for people who are doing massive amount of scan, you're looking at historical data for 2 years or 10 years, what has happened historically, right? And you're trying to do a lot of scientific computing on top of this data to make forecasts or make decisions. And for those, we recommend using a Gen 2 warehouse plus query acceleration to get the best performance out of it.
That was fantastic. Thank you so much. Because I think that's probably was one of my questions too. Do we still use interactive warehouses to scale up and down and like build a cluster with it? And I think we do. And awesome. I feel like I have a better understanding of what interactive analytics is and when to use this combo and what should be the performance considerations, like when should I use, when should I not use. And I also know how to ingest data into interactive tables and also how it supports the complex joins and window functions and whatnot. Tell me, is there anything else that I should know as a data engineer before I go build something with these today?
Yeah, so Snowflake Interactive is fully available, generally available today. We have both documentation and quick start guides. You can get started on those today. And then if you have any kind of questions, please definitely reach out to us through the community, and we're like there to help you to build those. As you have seen, sort of in the kind of working demo, it should be fairly straightforward, right? You take a table, pump it into a new format, and you get the same standard Snowflake experience on top of it.
Awesome. Yes. For folks who are watching, yes, definitely check out the quick start and documentation. Build it yourself today. And if you have any questions as you're doing this, like you want to give feedback, you tried something and you want to talk about it, feel free to reach out to us on LinkedIn or like the Snowflake forums, the Snowflake community. And I take the liberty to say you feel free to spam Will and his DM on LinkedIn too if you have any feedback, and that would be great.
Absolutely. Yes. We'll be there to help all of you.
Awesome. And I think before we wrap up, like giving one or two couple of minutes for last minute questions, if folks have any. Going 3, going 2. It looks like, Will, you did a fantastic job explaining what this is. And no more questions. Thank you so much. And thanks everybody for watching. We will come back next week with another exciting episode. Until then, happy holidays also if we don't see you next week. Thanks everybody.